All right, hi. Thank you guys for having me. And also thanks for coming out. I know it's been pretty rainy, but I appreciate you guys being here. I know you guys all came out to see the talk of how to add end-to-end encryption to your Angular application. And after giving this talk a couple of times, what I found is that I need to go actually a little bit more in depth. So I will pay off that promise of how to add end-to-end encryption to your Angular app, but I'm gonna go one step deeper and how to actually add data privacy to your application. So my name is Madison. I work for IronCore Labs. I'm a software engineer and developer evangelist there. So first, I just want to get kind of a show of hands, get a feel for the room. How many people use Angular on a daily basis? Probably a lot, okay. And then how many people would consider themselves senior devs? Okay. And then last question for you. How many people here have heard of the Cambridge Analytica snafu? Cool. Okay, so for those of you who know, I'm going to do a quick recap. And for those of you who don't, I'll kind of walk through it. So wasn't so great, right? So essentially, as users, we decide to share our data with a vendor like Facebook, right? We share our images, we share our likes, we share information about our friends, all that kind of stuff, right? Share that with Facebook. And then Facebook, through APIs and auth tokens, shares that with some of their vendors. So in the Cambridge Analytica case, they shared it with a personality quiz, right? Now, we as savvy internet users may not take a personality quiz like that, knowing that it might compromise our data, but a lot of users did. About 305,000 people decided to take this quiz, right? Now, it not only captured information about that individual user, but it also captured information about all of those users' friends, right? And then it packaged up all of that data that it gathered, and it sent it to Cambridge Analytica, who then used this data to potentially influence and sway an election. And this affected 87 million people. So the moral of the story is don't get sucked. But the real question is what did Facebook do wrong here, right? The users decided to take the personality quiz. They didn't do anything illegal. They shared it through an auth token and it was fine, right? So what they did is essentially they decided to share information with one of their vendors in plain text. And because of that, they lost control over that data downstream. And once they found out it was being used for malicious intent, they had no recourse to pull that data back or even see how it was being used, right? But what if I told you that there was a way that you could keep your data safe during the entire journey? So as app developers, we want to implement that into our applications. That didn't work. Okay, so what if you could control your data? What if you could decide who could have access to that data, monitor that access, no matter where, see how, when, and where that data is being used and how it's being accessed, regardless of where the data lives. So whether it lives on the cloud, whether it's an on-prem database, whether it's on disk, doesn't matter. We want to be able to see where it's being used, right? And what if I told you that you could revoke access at any point, no matter where it's stored? So we call this data control. And essentially, it's what I just told you. So it's the ability for a data owner to determine how, to see how, where their data is being used, and the ability to change their mind at any point and revoke access. Okay? So how do you implement this into your application? So first, I'm going to talk to you a little bit about end-to-end encryption and how to implement that into your application. Using things that you already know, like decorators, HTTP interceptors, stuff like that, Angular core functionality. And then I'm going to build on that a little bit and talk about transform encryption and how it gives you the added benefits of data control. And then lastly, I'll quickly touch on groups. So one thing also, too, if you guys have questions, just raise your hand at any point. I'm an avid question asker. I hate waiting until the end to ask my questions. So if you have anything. Okay. Any questions yet? Yeah. Transform encryption, I'll define it for you, and I'll explain a little bit about how it works. Actually, before I go to this, so who here has, what do you think of when you think of end-to-end encryption? Or encryption? Okay. What else? Telegraph? Okay. I'll talk about that in a bit. Tokens? Cool. So normally when I ask that question, one of the answers I hear is HTTPS. And this is how a lot of web developers decide to encrypt data. So that's essentially an example of encryption in transit. And it's securing data while it's traveling over the network. And that's all it's doing. Okay? Another common thing I'll hear is encryption at rest. So an example of this is transparent disk encryption. And the problem here is if it's transparent to you as a user, it's also transparent to a hacker, right? So this really protects against, essentially, my computer has to be off and somebody literally stealing my physical device of the computer, right? So not super effective. Another example here would be an S3 encryption module or MongoDB's encryption module, right? So these are securing data on the actual server, and that's another example of encryption at rest. So, but both of those two types of encryption together is not the same as end-to-end encryption. So end-to-end encryption is data should be encrypted from the point of origin to the point of use. Okay? So it looks like this. So we encrypt data on our application level. Then while it's in transit, it's encrypted. So if you add encryption in transit and encryption at rest, there's a seam here where before it hits the server, where that data is decrypted and then re-encrypted on the server, potentially if you're using encryption at rest, and then it goes to the client, right? So there's a point there where you actually lose control of that data because you have it in an unencrypted state. Does that all make sense? So one thing that's important to note is that 10 of the last security and privacy vulnerabilities were using both encryption at rest and encryption at transit, in transit, and so was Facebook. So it's not really solving our problem, right? So what we want to do is that we want to implement encryption in a way that is transparent to our application, so we don't need to worry about whether we're seeing encrypted text or seeing plain text. So we want to encrypt it on the seam, on the client seam. To do this, we're going to use HTTP interceptors. And what these are doing is they're used to pre- and post-process data in our application. So we're going to use an iron HTTP interceptor, which is essentially going to intercept a request determined based on policy that we implement into our application. And we're going to use decorators here. I'll come back to that. Based on our policy, we're going to decide whether to encrypt that request on the way out or just pass it through untouched, right? And then on the way back, we're going to decide, see if our response is encrypted. If so, we're going to decrypt it and pass it into our application. So we want to encrypt on the way out and decrypt on the way in. And we want our solution to be privacy driven. Does that make sense? Cool. Okay, I'm going to jump into a demo because I had great feedback last time that we needed to do demos, so I will do one. Let me first set the stage for you. So who here is a little bit nerdy and likes Star Trek? Come on. Who likes Star Trek? Okay, cool. So I have a nerdy Star Trek application that's going to show you how some of these core functionalities are implemented, and we'll kind of walk through a little bit later in the app, and I'll show you how it works under the hood. But first, this might mess up the live stream, just by the way.
It usually does, because that's a 4K. This happens.
Okay. So wow, that's very small. All right. Everybody see it okay? Cool. Okay. So I am Captain Kirk. I have, oh, I needed to check, make sure I'm running this. Not. Cool. Well, it's at 10%. That's fun. 92. 92 is the best. That's a stall there. That'd be solid. Oh, 92. There you go. Cool. All right. Make sure everything loads correctly. Cool. Cool. So we have our Starship Enterprise crew, right? We have all of our favorite characters, right? Cool. That's fun. All right. And then we want to encrypt in order, right? So we're just going to say, so we're encrypting from Kirk to our team. So essentially in Star Trek, just a quick recap. So basically the Star Trek Enterprise, Starship Enterprise travels around the universe and they go and explore new planets, right? And what they do is that they send a team down to go and explore this new planet, okay? And there might be Romulans who are on that planet that might compromise our mission. So what we want to do is that we want to be able to share or send messages to our team that's on that planet and have it be encrypted and secured so Romulans can't see it. Does that make sense? Cool. So as Kirk, I am on my ship. I am going to say set phasers to stun. We don't want to hurt them. Okay. I'm going to encrypt my order. Cool. So I can, as Kirk, I can see my order, right? But I haven't actually decided who I'm sending down to the planet yet, right? Let's just say I want to Sulu's still on my ship. He can actually see that there's an order to be decrypted, right? He can't see that something was said over the wire. And let me just actually make sure I have the most. Well, actually, let me restart that. It's not a big deal, but I added something that makes it more obvious. So. All right, 10. Cool. I should have just gone past it. Oh well. All right. Cool. So I'm encrypting my order. I can see it as Kirk. And then when I switch over to Sulu or somebody that's not in my group, I can't see the decrypted message, right? That's just a little bit better. I had to pull. Okay. So now as Kirk, I'm going to decide who I want to send down as my away team. So who should I add? Reg. Well, we know what's going to happen to him. Spock? Cool. Anybody else? Sulu. Let's do it. All right. Awesome. So now I'm going to switch over to Spock. You can see that he's on the away team, has a label. And I can go ahead and view that order, right? So the important thing to note here is that when I decided to encrypt my order, I didn't know who I wanted to encrypt it to. I decided that after my order was already decrypted or encrypted. Okay? Hold on to that thought for later. All right, that's the demo. Now, let's go through some fun screen share stuff where this is not going to work. All right. So, in order to implement this into our application, the first thing that we're going to do is we are going to create an order class, right? Super simple. This is just what we're basically defining as our message. And we are going to decorate that message with our IronCore decorator here. Now, you don't need to worry about what this actually does right now, but I will be coming back to it. Okay? But it's just super simple. It just has a title, a message, and an ID. Okay? The next thing I'm going to do is I'm going to create a service, an order service. Now, going to your question of the interceptor, right? The Iron interceptor is essentially just hooking into the post and get requests. And so it's just hooking into the simple HTTP request here. But just it's just CRUD, right? So as you can see here, I have create, list, get, and delete for all my orders. Just hooking in. And then I'm only deciding to do something if I see a certain field on that order, right? Which is added by that decorator. So that's how we're getting policy-driven access control. And then last thing is I'm just going to hook in my HTTP interceptor into my app. So that'll intercept all of the requests and responses. And that's it. Questions?
What is the encryption?
The encryption, I will talk about keys. Promise. Anything else? Cool. So what I've just shown you is how to use an HTTP interceptor to implement encryption and decryption into an Angular app. Super, super simple, okay? So that was my first talk. I ended there, right? Oh wait, I have one more little, because you can't have a good dev presentation without a GIF, right? So this was my first talk. Essentially, it was implementing end-to-end encryption, and that was it. But what I found is exactly to your question, is how are keys managed and what's happening under the hood. So I added a couple of bonus slides, and we're going to talk about transform encryption. So going back to that, the earlier question of what that actually means, we're going to cover it now. So what I've just done is, oops, that's wrong. That should be in order. So I've essentially taken a JSON object, I've encrypted it, and then I put it in kind of a secure encapsulation. And no matter where that data is passed, it's in its encrypted form, which gives me control over that data, right? But let's take a look under the hood about how this is actually working. So this is essentially just public key cryptography. So how many people have heard of that before and know how that works? Cool. Okay. So just quick recap for those of you who don't know. In order to, so basically every user in our system has a public and private key. Okay? Now, in order to encrypt a document to a user, we are going to use the public key of the user plus a document, and then we get an encrypted document. Okay? Then we use the private key to go ahead and decrypt that document later. And there's a mathematical relationship between the private and public key. Cool? All right. So for most of you, this might sound like GNU PG, right? This is a common implementation, something that we use as devs for our production keys and stuff like that, right? Which is a pain in the butt. And the reason why it's a pain in the butt is because we need to know exactly who's in our group before we decide to encrypt data to that group, right? So as a development organization, we use GPG, and we need to know every dev that's in our org before we can go ahead and decide to encrypt something to that organization or to those people, right? How many people have run into this? Okay. And then how many people have had to offboard somebody that's on your team? Which is a pain in the butt. And the reason is because you have to go ahead and decrypt that document and then re-encrypt it to every user inside it that you want to encrypt it to, right? So before I can encrypt it, I need to know every user that it's going to be encrypted to, and revoking access is a pain, right? So remember this idea of the decorator that I showed you, and the group ID, right? So groups are a level of indirection, and like any good computer scientist, we know that most problems can be solved with one added layer of indirection, right? And so we're going to use groups for this. And what groups are is that they allow us to separately decide what data to encrypt from who should be able to see that data. Okay? Make sense? Okay. So initially, we wanted to say, all right, I know as Kirk, I want to send an order, a message, to the away team, but I don't know who I want to be on the away team yet. Okay? And we know that red shirt always dies. So I want to then go ahead and decide to revoke access without changing the underlying data and without needing to decrypt and re-encrypt that data to every single person that could potentially be in that group. Does that make sense? Cool. Now, each one of the reason that this works is because we have a thing called the transform service. And the transform service essentially lets us encrypt data and transform it to another set of encrypted data with another user's name on it. So how many people know like the term plain text? Right? So it's never in a plain text state in this service. So we're transforming encrypted data to other encrypted data. So the way I like to think about this is like, this may be going off the cuff, but M&Ms, right? M&Ms have a little M on them, right? So essentially, I'm changing the name of the shell without ever unwrapping the shell. Okay? So what this allows us to do is, since we have a single kind of center point of a phone home functionality, we can, so it changes the name. We can see who's accessing the data, because every time data is being accessed, a log is generated from this transform service. So we can see who's accessing the data, how they're accessing it, and where, right? And then we have the ability to revoke access at any time. And so how this works under the hood is essentially the transform service. Always need to make a call to the transform service if you are going to transform something, let's say from, so I want to share something with Dan. So I'm transforming data that's encrypted to Madison, and I'm transforming it to Dan, right? So in order for this transform service to work, Dan's name needs to be on this log. I need to have granted access with him, right? At any point, if I decide to take his name off of that transform service, that transform will no longer go, right? So I can only, as this user on the other side, I can only access data in the encrypted form, right? So essentially, you can crypto shred the data because that person cannot access it.
Is there a separate key for someone that has access to change that log?
Is there a separate key for somebody who has access to change that log? So that you cannot change the log.
Sorry, not the log, the list of users access.
So it depends on it. So the data owner is the person who can grant access to the data itself.
Okay, so that's a whole separate key that's associated with that.
So they would have the ability to grant access if you are the data owner, or if you are a person on here who the data has been transformed to you, you can grant access to it. If you're does that make sense?
It does, yeah.
Okay. All right, this might seem like magic. And last time I got a lot of questions about how this works under the hood, so I'm going to cover it. So what it is it's public key cryptography using elliptic curve crypto for the key generation. And let's dive deep. So if I lose a couple people, I apologize, but I promise I'll pop back up and we'll talk about a little bit more about theory. But I'm going to talk about keys for a minute. Okay? So essentially, this is public key crypto, right? We have our group, which has a public and private key pair. So essentially, we just think about it like an entity, right? And I have a user that I want to go ahead and add to that group. So a transform key is generated that will, sorry, Brian, that will go ahead and transform data from the away team to Spock. And that key is in the transform service. Make sense? Cool. All right, so if I want to encrypt to a group, I just encrypt like I would to any other entity. So in our example app, Captain Kirk decided to encrypt to the away team, right? So we encrypted to the public key of the away team group. And he got an encrypted document to the away team, right? And then once, as a user, as Spock, I wanted to go ahead and access that document. I have access to the encrypted document itself. I make a request to the proxy, or the transform service, sorry, I shouldn't call it proxy. Transform service, to go ahead and transform that document to me. That file is then transformed to the individual user, basically putting a new name on the shell of the M&M, right? And then Spock can go ahead and decrypt that with his private key. Yeah?
So is the flow like they'll use the group's public key to encrypt it and it's held there, and then once a specific user requests access to it, it'll then encrypt it from the general public home of the group to that user's specific public key, and then they can use their own private key to get it from there. But nobody can really use their private key to get it from the group encrypted state without the transform happening.
Exactly. Yeah, so one thing I just want to note is that the transform service is not actually holding the data. So that's held separately. This is where the data can be held anywhere, right? So it can be on the cloud, it can be on-prem, it can be in local store, it doesn't matter, right? So the transform service is essentially handling the keys of the document, and it's transforming those keys of the document to that individual user. So there's a mathematical translation from the transform key to the keys of the individual user. So going back to your question. Yeah.
So the transform service is on the server side, not client side.
So the transform service is a separate service. So essentially you have your application, you implement an SDK that would make a call out to the transform service, or it could be embedded into the application, and that's separate. So it's not on the client.
Okay.
The transform service is not happening on the client. It's passing down that data. That can then be decrypted on the client.
And the transform service is what has the access control list.
Yeah, exactly. So that it has that list of people who are able to view certain documents.
So is there value in switching the encryption between these keys versus just having a key like on the group level for the access control list?
Is there value to say that one more time?
So you're basically just decrypting and re-encrypting for different users' private keys, but all the magic happens in the access control list part, like where you check that control list. So why not just have a key for the group, that you're controlling access for? Because you can still revoke permission at any time when they go for that.
Yeah, so a couple things there. So we are not actually controlling, so the access list is held on the transform service itself, right? And I think there was something where you said that you were decrypting and then re-encrypting to a different user. But the key here is that it's never actually decrypted. And so that's why the transform service is important, is because you don't want to decrypt it from the group state to a user state. You want to pass it through as encrypted text to encrypted text. And that's where the transform service is really important.
I see.
Does that answer your question?
I think so.
So in your demo example, you didn't have anyone assigned to the group yet. You were able to encrypt the document versus your slide where everybody, you have to have the entire group's credentials to encrypt the document so everybody can decrypt it.
Exactly. So I needed to know everybody I wanted in the group, and then I also needed to know all of their key pairs before I could add them in GPG, but like you said, not in the demo. Yeah, got it. Yeah.
Where would the mathematics lie in the transform service? What libraries is that sitting in that's accessible?
So it's not in a library. It's in elliptic curve pairings. And I'd be happy to send you a white paper or a couple on the topic. Okay. Yeah.
So the client-side decryption, is that like a custom thing or a widely available library?
The client-side decryption?
Yes.
So one thing actually I didn't mention in my example of the implementation of end-to-end encryption is that in that example, you could have used any encryption library with the way that I use HTTP interceptors and decorators, right? But what you don't get is you don't get this transform service. And then as far as the decryption library, I was using IronWeb in that. Yeah. Cool? Awesome. So, and then in order to revoke access, all I'm doing is deleting the transform key from the group to that user, essentially removing them from the group, and they can no longer view decrypted data. Okay? So, I've just gone through and talked to you about how to add end-to-end encryption into your application. We dug pretty deep into how the keys work under the hood of transform encryption. And then I've also shown you how one level of indirection can give you a lot of functionality in your application. And essentially what this is doing is this is changing the model from our data proliferation model to one point of access where we can control how, where, and when our data is being used. And it gives us the power to change our mind. And this is what data control is. So I have two asks for you. One, I'm working on a long-form blog post that covers a lot of these topics, and I'd love to get feedback from the Angular community. So if you are willing to take maybe 10, 15 minutes, read it, and give me some feedback, I'll give you a t-shirt and a gift card. And I'd love to hear your thoughts. And then last thing, I'm going to be a super nerd. So I've given this talk a couple of times, and I've iterated a lot as far as just based on user on audience feedback. So if you guys could give me this was really helpful, covered a lot of my questions, thumbs up. If it was interesting, but I won't use it, sideways. And if waste of time, I won't be offended, I promise, thumbs down. Where are we at?
It's really cool. 1, 2, 3 or something.
1, 2, 3. Cool, so I think we got 90%. Awesome, cool. All right, well, thank you. Yeah, what questions do you have?
Good question. So in the case of Cambridge Analytica, if they had actually decrypted it at that point, you know that was the endpoint that decrypted it, so at least you know where it went. Once they've taken it out and it's unencrypted, of course it's...
Yeah, so you lose control of the data when it's in a decrypted state, right? And that's...
You have to trust.
You don't so what this is trying to provide is essentially transparency, like you said. To your point, you want to be able to see who was able to decrypt that data, right? And so you would see at that point, well, why is Cambridge Analytica decrypting, making 1,000 requests a minute? What's going on, right? You would be able to have visibility into how that data is being used.
They don't care about the friends, they care about the person who sent it. Right?
Well, at least Facebook would have known. One of the big issues is that Facebook didn't know how the data was being used until way later. And they also couldn't revoke access. So, yeah.
So this at the very least, in the case that it's leaked, whoever receives that data can't see it, and if it is decrypted by someone that's authorized and they send it off, you would at least know they're the ones that screwed you over. Right?
Yeah,
That's the idea behind it.
and you potentially have recourse, right, to go ahead. And I mean, a lot of times this is actually implemented with legal contracts, saying that you can't hold data in a decrypted state in your system. So there would be some sort of recourse in a company scenario of how you would handle that.
Gotcha.
Yeah. Cool.
There's one thing that I wasn't sure was clarified. The transform service never has the ability to add or remove people from. It's not a normal access control list. That's cryptographically enforced.
Yep.
And it's never decrypted on the transform service. That's just turning one key into another.
Exactly. So how many people have written a bug ever? Cool. Yeah. So software-based access control has a lot of bugs in it, potentially. And so what this is doing is this is essentially handling it on the encryption level. So it's a cross-cutting concern. And for the architects in the room, that's really important because you want to know that your data is secure. You don't want to just trust that devs are never going to write a bug ever again. Yeah, good point. Thank you for bringing that up. Cool. Well, come talk to me afterwards. I'd love to get your thoughts on that article. And thank you for having me.